Welcome to the Land of House YouTube channel. I'm Seth. Today I'm working with Project Solar. This is a company that has been installing affordable solar panels for many years now, and they are branching out into the power station market. So today I have their 2,000 watt Project Solar power station. Now I'm going to be doing a three-part video series with Project Solar. So number one, we're going to review this power station. The video number two, we're going to be installing a transfer switch. This is basically a small breaker box that will allow you to turn off circuits for main grid power and turn on off-grid power. So let's say you have the power out for a day or two. You can hook up your internet, TV, refrigerator, and lights, whatever else you want to have on this system, and run it from this power station. So we'll be installing this into my shop so I can go from grid power to off-grid whenever I need to. And the last video in this three-part series is to try out the Project Solar Q-Cell 400 watt solar panel. This is what's going to recharge this power station whenever the sun is out. So if you're interested in these three videos, then continue watching. We've got a box in a box situation here. Very cool. All right, here is the AC charging adapter. Let's pull that out real quick. Now we can look at each of these components individually. So it is a sizable power brick here. Let's see what the watt value is. Lithium ion battery charger. Input 100 to 240 volts. It's a 6.2 amp max. Output is 42 volts at 15 amp. Next it has this little pouch. It's a nice zippered pouch with a water resistant zipper. All right, we've got a user manual here for the Power Bank 2000 watt. This looks like a rain cover for the power station. I'll dive a little more into that here in just a bit. All right, typical car cigarette lighter charger. You've got an MC4 charger and then another MC4 charger, so you can hook up multiple solar to this unit. Let me see if I can pull this power station out of here. It is a bit heavy. Yeah. Okay, and there's the power station. It does have wireless charging. You just place your device right here and it can charge. It has two rubberized grip handles. Also, each of the corners is coated in rubber so that if you do kick this around a little bit, it has a little protection for itself and other stuff. On this side, the unit does have a battery extension port, so you can connect a second battery, 24 volt DC right here, and expand your system significantly. I don't have one of those batteries to test out, so we will leave that there. There are two fuses here that can be removed to basically reset this if for some reason you put too much amperage or voltage into the system. You've got two slits for cooling, and that will help the unit not to overheat. Now if I turn it over to this side, you've got a sticker back here which just gives you some information about the power station, such as this is a lithium iron phosphate battery. It is rated at 1,920 watt hours. It's a 25.6 volt system, 75 amp hours. And there's other information here. It's 2,000 watt, 120 volt at 60 hertz. And then you've got various charging and discharging information, which we will get to here in just a moment. All right, let's turn this back to the front panel. So the first stopper is a DC input barrel plug at 100 watts. You could use your car charger for that one right there. Now over here, you've got two MPPT charge controller inputs, both of them at 600 watts for a maximum of 1,200 watts. The voltage range is 32 volts to 95 volts. So either one of those that you plug up to either a solar panel or to your AC wall brick will allow you to charge this unit up to 600 watts per port there. All right, now you've got 1, 2, 3, 4, 5, 6 AC output, and that's just your typical receptacles there, and those are a max output of 2,000 watts amongst all of those. Up here you've got your display, a DC and an AC power button. Over here is the DC output side, so you've got two barrel plugs, and these are rated 12 volt 10 amp. And then over here you've got your typical cigarette lighter style and that has a good rubber stopper to keep any debris from getting in there. And then lastly, you can flip these tabs here to reveal the USB. So we've got 100 watt USB type C right here, and then an 18 watt right there. You got an 18 watt USB type A over here, and then you've got 3 5 volt 2 amp USB down there. So plenty of output options on this power station. All right, let's go ahead and turn this unit on and see what the display looks like. I'm going to press and hold the AC button until the display pops up. Looks like this unit was shipped at 68%. It's got 87 hours left with no output. You can see here no watts being outputted, and it's got a little time right here, 87 hours. AC output is on, 68%, and then this is just a battery meter. And you can see 121 volts, 60 hertz. Turn that off. Now I can also hold down the DC button at the same time and bring up some more information. Now with the DC only, it's consuming about 1 watt just being on. It'll run for 435 hours with no output. 26.2 volts. It is possible to turn on both the DC and the AC output at the same time. And there you go. That's the basics of this power station. Now there are some methods for changing the hertz value if you need to. Since I'm here in the US, I don't believe that I'm going to be messing with that. So we'll leave it at the 60 hertz down here. Let's test out the 3 input methods for this power station, starting off with solar. Now I've got the 400 watt Q cell panel raised up here. Now this is by no means an ideal angle, so we'll just get some input here. All right, I'm going to use the MC4 connectors, which you can see right here, and the adapter that goes to the power station, and we will plug this up and see if we get anywhere close to 400 watts. Now the power station is turned off. I want to see if plugging up solar is going to automatically turn that on, because that would be highly ideal if you did not have to go out and manually turn this on each time you wanted to charge it. So let's go ahead and plug up the MC4 connectors. Got the positive and the negative, and let's go ahead and plug this up here and see what happens. Nice. The screen has popped on immediately. Let me get the shadow off of the panel here. All right, there's 300 watts. That MPPT charge controller is going to find the most ideal volts and amps here, and it will allow this to charge at maximum. So let's give that a moment and we'll see what it gets up to. Currently at 68%, so it's going to take 2 hours to charge up, 1.9 hours at 300 watts. Now one thing to note with solar, any shadow on the panel is going to reduce the watts. So we've got what, 238, and it's because my head is on the panel here. But as soon as I drop my head down, you can see this panel is now working at 300 watts. So even a small shadow on the panel will make a huge difference in the solar output. Looks like at this panel angle, 300 watts is about all we're going to get. Let me go ahead and disconnect this. And now I want to plug up the power brick and see what kind of power we get out of this. And then we will do a combination where we have both of them running at the same time. So let me go ahead and get this power cord connected here. Very nice. I've plugged up the unit and I don't hear any fan noises, which means this does not consume power whenever it is plugged up but not hooked up to the power station. So, all right, the unit is off now, which is good. Let's go ahead and plug this up and see if that will turn it back on automatically. And it does. Very good. I know there's a bit of glare, but hopefully you can see that it's running at 550 watts off of that power brick. All right, so now the test I want to see, what happens if you plug up the solar alongside that, because it's supposed to be able to have a maximum charging input of 1200 watts. So will it go above 550? Oh yeah, sure will. There's 840 right there. Very cool. So yep, that did add another 300 watts to it, and the charge time is now 0.6 hours. So let's see what it was. We're now at 70% on the charge. So Very nice. If you have a solar panel, you can definitely charge with both that and the wall plug at the same time. It's about 85 degrees out here today, and the fans just kicked on for this power brick. They're not terribly loud, but definitely audible. When that happened, the power output dropped by about 5 or 10 watts, but it looks like it's climbing back up again, so maybe that MPPT charge controller had to readjust when that fan kicked on. Not sure if that's true or not, but the Q cell is pumping out over 300 watts and doing well, but we will do a much more in-depth review of that panel in the future. It's also slightly hazy out today, so maybe affecting the panel. All right, so we are currently at half an hour left for this to be charged, running at 844-45 watts, 74%. When this is done, we will begin our discharge testing of this unit. I cleaned the solar panel off one more time, and I'm seeing 868 watts, so it is cooking up some pretty good power now. 0.4 hours, 78%. The display now says 100% on the state of charge, and it's got 0 hours left to charge, and I'm seeing 740 watts still coming into the power station, so it must be right there on the edge of turning off with 100% charge. I waited a few more minutes, and the fans have turned off on the AC adapter. The power of the unit is 3 watts, and it is 100%, so basically the batteries are now charged. So you do have to wait a little bit longer after it says that it's at 100% before it's good to go. I unplugged those, and the unit turned the display off, so awesome. You know what that means? Whenever there's no more solar or power coming in, the unit will turn itself off, and you don't have to worry about it sitting there and consuming power. Awesome. Very cool. Now that I have the power station fully charged up, it's time to do a discharge test. First of all, I'm going to be using a kilowatt meter. This will do 3 things. It will keep track of the time, keep track of the watt hours used, and also show us the current watt output from this machine. And then I'm also going to be using this heater, which is very consistent with its output, and so we should be able to get a nice consistent test. Nothing says fun like running a heater when it's 87 degrees out. So let's go ahead and begin this test outside. I'm also going to use my cell phone to keep track of the time in case this one were to cut out. So, all right, let's go ahead and hold down the AC button, turn this on, plug up the kilowatt over here so we can still see the display. All right, so the kilowatt meter will keep track of time, and then my phone will here as well. I'm going to turn this heater all the way up to the highest setting. Push start here on my phone. All right, let's see what kind of output we've got here. You might not be able to see much with the glare again, but we've got 1,392 roughly watts on the kilowatt, and here we've got 1,420 watts on the machine, saying that it will run this for 1.1 hours. Let's do the math real quick and see how long this should run. Let's use this number here. So we got 1418, I believe. So the mathematics behind this, you do the watt hours of the machine, so 1,920 watt hours times 0.85, because you don't want to discharge this fully. And then you divide that by your load, which is 1418. So 1.15 is our value here. So I feel like the 1.1 showing on the display is accurate. After 55 minutes, the display says 22% left, 0.2 hours remaining. And the watts are at 1,410 on the display. Pretty consistent. So I feel like that's the number we should use, about 1,410. At an hour and 10 minutes, we are at 1% here on the power station. So it should be turning off at any moment here. Let's see what we got on this. We've used 1.63 kilowatt hours. All right, there's our time. So we had 1 hour and 11 minutes. Very cool. All right, so the power station ran for an hour and 11 minutes and used 1.63 kilowatt hours. This is rated at 1,920 watt hours, which means we didn't quite use the full potential, but with these units, having the inverter just being on for an hour and 10 minutes is going to use a good bit of that. And then also, you don't want to have that full 100% of that watt hour range used up, and so you use a little bit less of it. So, but as far as the time goes, it was spot on for what we calculated versus what the power station display showed, and I am very pleased with that. So, now that we've done the AC test, let's move on to some DC testing. Now that we've seen the AC side of this power station, let's swap over to the DC side. First of all, I've got this air compressor, which takes a pretty good bit of power. I'll go ahead and pop open the 12 volt right here, and then click the DC button, or hold that down I should say. All right, turn that on. Okay, right away, this air compressor fan turned on. Push the power real quick. Very good. All right, that means it has plenty of amperage there to allow that compressor to work. All right, next I've got a flashlight that needs just a regular USB. So let's go ahead and open one of these and plug that up. I doubt you'll be able to see that, but it does have the little red light on there to show it's charging. And we've got 4 watts here on the power station, so that's working. I've got one of my kids' tablets here, so let's first try out the 100 watt USB Type-C and see if that will work. It's totally discharged. Let me give that a second to kick on. All right, I'm seeing the battery indicator there, so that's working. Power station now has 6 watts. All right, there's also a cell phone charger. Let me try putting my cell phone up here. Well, I tried placing my normal cell phone here on the wireless charger. Nothing happened. I tried taking it out of the case. It does have this little blip up here where the cameras are. But I did that, nothing happened. So then I went and got one of my old phones out of the house and put this up here. And I don't know if you can see it or not, but it started charging immediately. So it's working. Just some reason my normal cell phone that I've been using is not picking up here. So I'm not sure what the reason for that is. But anyway, wireless charging is working on that. So if I pull that out, you can see it popped back on. Okay, well, all of the DC stuff seems to be working. I probably can, yep, so that's got 7% now on this kid's tablet. So, cool. All that's working. All the functions seem to be doing as expected. The last thing I want to try out here is this cover that came with this unit. So, I'm going to go ahead and just stretch this around. I'm assuming that the zippered door goes on the front so you can access all of the stuff on the front. So, go ahead and get this pulled down into position. So, it basically covers everything. So my first thoughts are, if you're going to do that, it's going to limit your airflow. And so if you are going to be using this cover, I would make sure that maybe you're just using the DC stuff and not the AC. Otherwise, you may have a fire issue. I don't know, maybe not. But so you can unzip this water-resistant zipper and fold this up to access all of the stuff here on the front panel. And what I'm seeing here on the back of this little zipper pouch, there is a little Velcro tab and also another zipper. I'm guessing this is so you can reach in and grab your cell phone if that's charging here on the top. So yeah, if you have to be out in the woods or outside, then this cover would keep the rain off of the unit and allow you to continue using it. But I would just be cautious if you're going to be running AC loads that need a lot of airflow to cool this unit off. Then be careful, because this pouch will definitely prevent air from getting to those fans. All of the features on the Project Solar Power Bank 2000 seem to be working properly. This is part 1 of 3 in this series. So the overview of the power station, I like it. It seems to be working just fine. The only thing that I would change on this, well actually 2 things. I would like to have an internal AC to DC converter so that you can just plug this straight up to a wall and not have to have the large power brick. And the other thing I would change is adding a UPS or uninterruptible power system or power source. That way you can plug up the power, plug up the device, and if your grid power goes down, it will just swap over and start using this device. Other than those 2 things, this is working as it should. So the next thing that I'm going to be covering in this 3-part series is hooking up that transfer switch into my shop, and that way I can turn the grid power off and run my shop off of this power station. And then finally, the 3rd video is going to be covering the Q-Cell 400 watt solar panel that Project Solar sells. Alright, thanks for watching. I'm Seth with Land a House, and I will see you in the next video. Bye.